And welcome back. As we go ahead and dive into our next programming lesson, we're going to now take a look at how to troubleshoot our code when we start encountering issues. And the first way we're going to do that is through the use of tracing variables. So let's just say we're working on code and we start running into issues with it. Well, that's because a lot of times when we start writing code, it may not behave as we expect it to. When this happens, we often need to utilize what's known as debugging to look for and address errors with that code. Now note, this of course is different from creating proper algorithms to solve problems. So it's not part of the problem solving process, but rather it's part of the process for us to fix issues that we have. Now there are several types of errors that programmers typically encounter, and we're going to look at those before we dive into some of the techniques we need to solve them. And while there are many different techniques that we can use, the simplest one is the one we're going to use first, and that can be very, very useful for helping us solve potential issues with the program. So first, let's look at those types of errors. The first thing you need to know is what's known as a syntax error. This is typically an error that's due to something like a misspelled variable, class, or an object. It can also occur when you forget to include proper closing punctuation, such as a semicolon. So these are very common ones. These are the ones that you're going to see very easily. All right, the code won't compile with a syntax error. If you're using Eclipse, that's going to do on the file compiling, and so you can see immediately if you have a syntax error. It's going to be those little red squiggles that you see in your code. We've seen these types of errors probably already in our code, and again, these are very easy to spot, very easy to correct as well. The next type of error is what's known as a runtime error. This is an error that occurs when you're compiling and executing the code. So in other words, like it looks great, looks fine, but then you go to run it and it would have an issue there. And the last one is probably the hardest one to find. This is what's known as a logic error. This is an error that occurs due to an error in the programming code that renders certain code either unreachable or produces an undesired result. Compilers don't often pick up logic errors, though they get better at doing so. Most of the time, these are things that are going to be things that are in our algorithm that we're going to need to go back and fix, or maybe something in how we implemented our code structure needs to be tweaked or modified. Now, when we start looking for errors in our code, let's do this through an example here to see if we can try to start troubleshooting this. So we have int n equals 10, int sum equals 10, while n is greater than 1. And inside this loop, we have sum equals sum plus n and minus minus. And we're printing out the sum of the integers 1 to 10 is sum. All right, seems like a simple enough program. But what is the error? See if you can figure out what that error is before we actually start looking at some techniques to troubleshoot that. All right, so how can we troubleshoot? Well, the first way we can do this is through the use of trace statements. A good way to discover there's an error in your code is to trace the variables. This can easily be done by using system.println statements. A trace statement simply just keeps track of the value as a variable as it's moving through your program. So every time, for example, if it's in a loop, you can print out that variable each time it moves through the loop so you can see how it's changing with each loop iteration. These trace statements therefore function as, if you want to think of as watchers for those variables, they give the programmer a window into how that variable is being modified. Now there's no limit to the number of trace statements you use, but obviously we want to make sure that we frame them with purpose. We don't simply want to put a trace statement in everywhere, for example. That would just get messy. We'd have a whole bunch of println statements that might be overwhelming. We may also only want to trace certain pieces of our code at a time, so we can kind of troubleshoot and fix certain segments rather than trying to troubleshoot everything all at once. So when we start looking at debugging by tracing, let's go back to that code that we saw previously, but with trace statements applied. And you can see in here we have println statements that are outputting n in sum. And we could, of course, just have this print out n and print out sum. That's fine. But by adding a little bit of string context here, we say at the start of the loop and at the end of the loop, it allows us to know what are we actually defining here. I mean, experienced programmers for something like this could very easily just come and just print out n and sum. But if you are especially starting out, it's very good sometimes to also add a little context here as to what you are printing out, simply so that way you know exactly what you're looking at. Especially since if you don't remember which variables to go to, or if you have a large program and you have multiple things that you're trying to track, it's good to add some context here to our print line statements. Now, if we were to actually run that code, what would we expect to see? All right, well, we would see at the start of the loop n equals 10, at the start of the loop sum equals 10, at the end loop n equals 9, at the end loop sum equals 20. All right, and that's just from running that code. This is though after one iteration of the loop. And you can see immediately just from that first iteration that there's something wrong. Well, because we know 20 is not the sum of numbers 1 to 10. All right, and this is due, if we think about it, our sum was initialized to 10. All right, so we'll look at how to troubleshoot this in a minute here, but let's look back at cleaning back up our code, right? Now we can easily go back and address that issue with our loop in order to solve the error. But the thing I want to really iterate is that once we're done, once we do fix that error, don't forget to go back into your program and remove any trace statements that you currently have in there. Trace statements are not meant to be part of your final program. These are temporary lines of code, and because they're temporary, we want to remove them once we're done because we don't want that in our end product. And now real quick, I'm going to go ahead and run that code just so you can see it again. So here we are in close to the exact same loop that we saw previously. So if I go ahead and run this, you'll see that of course it iterates through each of those cycles of loops, showing me those values. And so it'd be very easy for me then to say, oh, well, what is the issue? Well, we said sum starts at 10. So from here, since I know that sum starts at 10, I can start saying, well, what do I need to change it to? So for example, let's just say I go ahead and change sum from 10 to 1. Is that going to make my program correct? Because maybe I say, maybe I have my sum starting at too large a value. So I can easily go in here and change it. And just by changing it from the sum of 10 to 1, if we rerun this program, you can see that we have much more accurate numbers than we would expect because we're starting at 1 and then we're going to 11, etc., etc. However, it may not be exactly what we want because a lot of times when we're adding something, we don't have a initial value. So we would have to adjust this, for example, making sum 0, because that would give us then a true starting value for our program. And if I ever do that, if I do sum as 0, all right, you can see that we now have, n starting at 10, sum is 0, and then at the end loop 9, sum is now 10 at the end loop, which makes sense because we're starting first with 10. All right, and then of course, if we look near the end here of our program, at the end loop n equals 1, sum is now 54. So the sum of numbers from 1 to 10 is 54, which is of course a lot more in line with what we expect this to be versus what we had originally with our numbers. And when we start looking at these, don't forget that with your trace statements that you can take these out. A couple things I can also note too is if you're like, hey, I don't want to fully take these out because maybe I haven't fully debugged my program. Don't forget you can also just comment out individual lines here as well to take those out, for example. And now you wouldn't leave these commented lines here necessarily in your final program, but you would put these here just if you're troubleshooting something. So when I go ahead and run this, you notice again these are commented out so they don't show up. Because now we just see at the end of the loop, at the end of the loop, at the end of the loop, because these lines are commented out. Ultimately, though, I would, when I'm done with my program, remove these lines of code because I'm going to have no purpose for them. So again, just some quick things. It was giving us our first technique of how to kind of troubleshoot a program and look for if we are not getting the expected value that